So we want to quickly look at application of differential calculus, rate of change, rectilinear motion, minimum and maximum value. Rate of change. So we can sometimes refer to the y dx as what? Rate at which y is changing with respect to x, which we have mentioned before. And a very thing you need to note here is if we are requested, they say rate at which area changes, and that is what we refer to as the a over the t. If you are given a parameter area with respect to r, you can differentiate area with respect to r, which is the a dt, and you have another function r as a function of t, or rate at which r changes, that is the r dt. So if you look at this, the a dt, this equation you are seeing on the screen, you notice that the r and the r can cancel out, so we still have our the a dt. So this is the kind of thing we do in rate of change. To get the rate at which a changes, when we know the a, the r, and multiplies it by the rate at which r changes, we can still have our dA dt. So this is the kind of thing we do in rate of change, which are very obvious in the examples given in the module. Rectilinear motion. This is the motion of a particle along a straight line. Whenever any particle moves along a straight line, we're talking about rectilinear motion. What is very important for you to know here with respect to differentiation is velocity v is usually what? The x dt, where x is the displacement, velocity is the x dt. So when you have the x dt, just note in rectilinear motion we're talking about velocity. So these are the terms you need to get yourself acquainted to. So the x dt is velocity. Okay. If we are told that the particle is momentarily at rest, it means at that point the velocity of that particle is 0. So it means the x dt is 0. So when you see in a question that telling us that a particular particle, a body, is at rest, it means at that point our the x dt is 0. How about acceleration? Acceleration is dv dt. That's the rate at which velocity changes. Acceleration a is dv dt. And recall that our v in the last slide is the x dt. So if I put that here, so we have, if I differentiate the x dt, I can still have my acceleration. The result of the x dt, if I differentiate the x dt, I will have my acceleration. So these are the things we need to know. So acceleration is equal to the 2x over the t squared. The 2x over the t squared. So when you have, it means if you are given x as a function of time, so if I differentiate 2 times, if I differentiate displacement once, I'm going to have velocity, and if I differentiate that result again, it will give me acceleration. So it means I will remember we have done higher derivative. So if I differentiate displacement 2 times, I'm going to have acceleration. Minimum and maximum values. What is important for us to know here are the conditions, the necessary and sufficient conditions for a maximum point at x equals to a on the curve y equals to f of x. These are the conditions. At maximum value, the y, the x is equal to 0, and the 2y over the x squared is usually less than 0. Is usually what? Less than 0 for maximum point. If it's less than 0, then that point is a maximum point. At the y dx, the first condition, the y dx is equal to 0. The second condition, the 2y over the x squared is less than 0. Now the necessary and sufficient conditions for a minimum point at x equals to a are the first one, just like the previous one, the y dx is equal to 0. You see the first conditions in both cases are the same. Now in this case, the 2y over the x squared is greater than 0. That's for minimum. When it's greater than 0, then it becomes minimum point condition. Good. Thank you for your attention.